study a topic from the chemical kinetics. The first topic, what is rate? The, what is the rate of reaction? Students, if we see the chemical reactions, for example, first reaction I will write here, the reaction between silver nitrate and sodium chloride. To use silver chloride and sodium nitrate. Or I will write, this is the second reaction I will write, for example, reaction between sodium hydroxide and hydrochloric acid to give sodium chloride and water. Or I will write another reaction between barium chloride and H2SO4. It gives barium sulfate and hydrochloric acid. I have written these reactions. First reaction, this is the ionic reaction. Second, it is the neutralization reaction, and this is also barium chloride and H2SO4. This is the precipitation reaction. These reactions, which I have shown here, these reactions occur in a fraction of a second. These are very fast. So first we study the reactions which are, whether it is neutralization reaction or ionic reaction, in which there does not occur breakage and bonds but only ions are involved, exchange of ions takes place, and precipitation reactions. These reactions are very fast. They take within a fraction of a second, even 10 raised power minus 10 of a second. Now I will write another reaction. For example, hydrolysis of ethyl acetate, esters, hydrolysis of esters. For example, I will take ethyl acetate. Reaction of ethyl acetate with sodium hydroxide. It gives sodium acetate and ethyl alcohol. Sodium acetate and ethyl alcohol. Or if I will take decomposition of hydrogen peroxide, it gives water and oxygen. Or I will take second reaction, inversion reaction, inversion of cane sugar. It gives glucose and fructose. So these reactions, whether it is hydrolysis of esters, ethyl acetate and sodium hydroxide gives sodium acetate and ethyl alcohol, decomposition of hydrogen peroxide, or the inversion of cane sugar, these reactions take place at moderate rate. That means their rate can be measured. Another type of reaction, for example, if we take the example of rusting of iron. This reaction takes place very slowly, and it seems that the reaction does not occur, but it occurs. So we categorize the reactions into the very fast reactions, another moderate reactions, and very fast. But we are concerned with these reactions whose rate can be determined. And what is the rate? Students, if we see in case of automobiles, you determine the rate distance traveled divided by time taken. You define the rate as distance traveled in per unit time. Now in case of chemical reactions, for example, I will write a reaction A. It's a hypothetical reaction. A gives products, A gives B. A is the reactant, B is the product. During the reaction, you know, concentration of A decreases, or we can say the A, which is the reactant, it disappears, and B is the product, it now it begins to appear and it appears. So I will write rate of reaction is, it is the rate of disappearance of A, और चूंकि कंसंट्रेशन इसकी कम होती है, इट इज रेट ऑफ चेंज, इसकी कंसंट्रेशन चेंज होती है, चेंज इन कंसंट्रेशन ऑफ ए। और अगर हम प्रोडक्ट्स की बात करें तो रेट ऑफ अपीयरेंस ऑफ बी, और वी कैन राइट ऐसे लिख सकते हैं, इट्स चूंकि रेट इसकी चेंज ऑफ कंसंट्रेशन ऑफ बी, यानी ए तो हमारे पास रिएक्टेंट है एंड बी इज द प्रोडक्ट। व्हेन द रिएक्शन स्टार्ट्स, concentration of A decreases, that it begins to disappear, and B is the product, now it appears. I have written rate of disappearance of A, और rate of, और दूसरे तरीके में लिखेंगे rate of change, क्योंकि concentration इसकी change होती है, that is rate of change in concentration of change in concentration। क्योंकि B appear होता है, it is the rate of appearance of B और rate of change in concentration of B। so for example, मेरे पास एक initial concentration है A1, तो रिएक्टेंट की, तो अब फाइनल ये इनिशियल कंसंट्रेशन है। अब बी की जो फाइनल अब रिएक्शन हो रही है, तो इसकी जब मैं नाप रहा हूं तो इसकी कंसंट्रेशन उस वक्त A2 है, तो चेंज इन कंसंट्रेशन मेरे पास रहेगी डेल ए इज इक्वल टू A2 फाइनल कंसंट्रेशन minus initial concentration A1। I have shown this A in square brackets. Square brackets means it shows the molar concentration. Square brackets indicate the molar concentration. That means final concentration minus initial concentration जो थी, तो वो आपकी डेल ए रही। क्योंकि साइन जो आ गया, क्योंकि ए में जब अपेयर होता है तो फाइनल कंसंट्रेशन माइनस इनिशियल कंसंट्रेशन जो है, साइन आपकी माइनस आ जाएगी, क्योंकि इनिशियल कंसंट्रेशन बहुत ज़्यादा थी एंड फाइनल कंसंट्रेशन जो इसकी थी कम रह गई रिएक्टेंट की, तो आपका साइन माइनस साइन आएगा। दैट दिस माइनस साइन इंडिकेट्स दैट कंसंट्रेशन ऑफ द रिएक्टेंट्स डिक्रीजेस, कंसंट्रेशन ऑफ द रिएक्टेंट्स डिक्रीज। सो इसको हम टाइम डेल टी के साथ टाइम करें, क्योंकि आपका अगर इनिशियल टाइम T2 था और फाइनल टाइम T1 था, initial time t, final time T2 and initial time T1, so del t is the change in time। so rate हम डिटरमाइन करेंगे, रेट इज इक्वल, रेट ऑफ रिएक्शन कैसे करेंगे इस रिएक्शन में, तो वो करेंगे माइनस डेल कंसंट्रेशन ऑफ ए डिवाइड बाय डेल टी। माइनस साइन इंडिकेट्स दैट देयर अकर्स कंसंट्रेशन जो आपकी ए है रिएक्टेंट्स, दैट द कंसंट्रेशन ऑफ द रिएक्टेंट्स डिक्रीजेस। अगर हम प्रोडक्ट्स की बात करें, सो रेट इज इक्वल टू वी विल राइट ओनली द पॉजिटिव साइन व्हिच वी विल नॉट शो, दैट इज इट इज डेल concentration of B divided by del T, because concentration of the products increases। so इस तरह हम रेट लिखते हैं। फॉर एग्जाम्पल आई विल राइट a reaction here, PCl5 gives PCl3 plus Cl2। so if we write this rate, this is del concentration minus sign दिखाना है, minus del PCl concentration of PCl5, you have to write PCl in square brackets divide by del T। अगर हम इस वे, अगर we can determine the rate find from any one term of the reactant or the product is equal to, so rate is equal to minus PCl5 by del T, और अगर PCl की तरफ से, so it is del concentration of PCl3 divided by del T, और इज इक्वल रेट कैसे करेंगे, या Cl2 से, सो इट इज डेल Cl2 concentration of Cl2 divided by del T। so we write here, we determine the rate by change in concentration divided by time taken, change in concentration of products divided by time taken। so in case of reactants we show the negative sign which indicates that the concentration of the reactants decreases, and that in case of products we write we do not show the sign, it is the positive sign actually, so which means the concentration of the products increases। now students, here in these reactions I have shown, if I write this A plus B gives C, now this is the reaction, you know stoichiometric coefficients are same, I will write simple, this is the simple, this is del minus del concentration of A divided by del T is equal to minus del concentration of B divided by del T is equal to del concentration of C divided by del T. In case of reactants, you have to show the minus signs, and in case of the products, there is the plus sign. Now, in these reactions, the stoichiometric coefficients are same. Now, I will write a reaction A plus B gives twice C. This is one of the reactions. If this is the here, stoichiometric coefficients are not same. Now, this what does it mean? It means that rate of disappearance of A is equal to rate of disappearance of B. अब A और B, जितना A आपका डिसअपियर होता है उतना ही B भी, लेकिन जो C है दैट इज ट्वाइस इज इक्वल टू ट्वाइस रेट ऑफ अपीयरेंस ऑफ C. प्रोडक्ट्स ट्वाइस है. अगर हम इसको यूनिक या मैं दूसरे तरीके से लिखता हूं, अगर मैं इसका ट्वाइस खत्म करूंगा, सो दैट इज ट्वाइस. यहाँ पर 1 mole of A reacts with 1 mole of B gives 2 moles of C. So I have written rate of disappearance of A is equal to rate of disappearance of B is twice rate of appearance of C. But अगर हम यहाँ twice लिखेंगे तो मैं लिखूंगा twice rate of disappearance of B of A is equal to twice rate of disappearance of B is equal to, अब यहां पर ट्वाइस, यहां पर इज रेट ऑफ अपीयरेंस ऑफ ए इज इक्वल रेट ऑफ अपीयरेंस ऑफ सी. अब सी में मैंने ट्वाइस खत्म किया, यहां पर ट्वाइस किया और यहां पर इज रेट ऑफ अपीयरेंस ऑफ सी. तो टू गेट द यूनिक वैल्यू in case in terms of rate, we divide the rate shown by any one of the reactants or the products by the stoichiometric coefficients. हम stoichiometric coefficients के साथ डिवाइड करते हैं. सो इसमें we write it is the rate is equal to rate इस रिएक्शन में I will write here A plus B gives twice C. so इसमें रिएक्शन कैसे लिखेंगे, that is rate is equal to minus del concentration of A divided by del T, क्योंकि divided by del T is equal to minus del concentration of B divided by del T is equal to 1 by 2, क्योंकि वहां पर 2 stoichiometric coefficient में 2 is 1 by is equal to 1 by 2 del concentration of C divided by del T. तो इस तरह हम रेट लिख सकते हैं. फॉर एग्जाम्पल आई विल राइट इन दिस एग्जाम्पल that x times A plus y times B gives Q times C plus L times, let it is L Q L times D. So कैसे लिखेंगे, it is rate is equal to minus del concentration of A. तो पहले हमें लिखना है 1 by x del concentration of A divided by del T. So we have divided the stoichiometry here is x, here it is y, it is q, it is c, it is l. So we have determined the rate determined by any of the any term of the reactants or products by their stoichiometric coefficient. So I have divided this rate term by x and is equal to minus 1 by y del concentration of B divided by del T. इसी तरह 1 by q is equal to 1 by q del concentration of C divided by del T. So इस तरह हम stoichiometric coefficient से हम डिवाइड करते हैं. Now this reaction you have seen, this is the average rate. As you know, this is the average. I have taken the concept from the automobiles, from mechanical speed, that distance traveled divided by distance traveled divided by time. I have taken that concept. But in case of the chemical reaction, average rate, I have taken the mechanical concept here, that distance divided by time. But in case of chemical reactions, concentration changes. आप देखते हैं concentration of reactants keeps on decreasing, and that of the products that increases. So in chemical reactions, कंसंट्रेशन की रिएक्टेंट जो रिएक्टेंट की कंसंट्रेशन वो कम होती है और प्रोडक्ट की इंक्रीज होती है. सो चूंकि रेट डिपेंड्स अपॉन द कंसंट्रेशन, सो रेट डज नॉट रिमेन कांस्टेंट. सो हाउ वी कैन डिटरमाइन? So we have to take the instantaneous rate. Instantaneous rate means the rate at a particular moment, rate of reaction at a particular moment of time, particular moment of time. So that means actually when mathematically हम क्या time limit को हम very small, it is made small. Time we do time limit, time जो आपके पास है is made so small, that means the rate remains constant. I will show. हमारे पास del concentration of A divided by del T था. In case of reaction A gives product B. So I will write, if I will take time limit, time is equal to 0 in case of differential calculus. When del A del time limit is equal to, when time approaches 0, we can write del A by del T is equal to dx by dx by dt. Yeah, it is called dA by dt. I say. So applying this concept, we'll write then rate is equal to d minus d concentration of A divided by dt is equal to d concentration of B divided by dt. ऐसे लिख सकते हैं. फॉर एग्जाम्पल अब जो मैंने आपको पहले बताया, if the reaction the stoichiometric coefficients are not same, then we have to divide it. For example, I will write twice N2O5. A reaction gives 4 times NO2 plus O2, decomposition of dinitrogen pentoxide. So this is 1 by 2 minus 1 by del. अब आपको D लेना है, D concentration of N2O5 divided by del T dt. अब dt लेना है is equal to 1 by 4 D concentration of NO2 divided by del T is equal to D concentration of O2 divided by del T. So ऐसे लिख सकते हैं हम रेट. फॉर एग्जाम्पल मैं आपको लिखूंगा small a times A plus small b times B gives small x times x plus small y times y. This is the rate. So I will write it is 1 minus, चूंकि reactants है हम we have showed minus sign to, which indicates the rate decreases. It is minus d concentration of A divided by dt is equal to rate किसके बराबर है, इज इक्वल टू जहाँ इससे निकालते हैं हम इस दूसरी टर्म से, इज इक्वल टू माइनस डी कंसंट्रेशन ऑफ बी डिवाइड बाई डी टी इज इक्वल टू 1 बाई एक्स, यहाँ पर 1 बाई बी, यहाँ पर 1 बाई ए लिखिए डिवाइड 1 बाई ए जो आपका कंसंट्रेशन जो स्टोइचोमेट्रिक कोएफिशिएंट डिवाइडेड बाय दैट, यहाँ पर बी है इट इज 1 बाई बी, सो यहाँ पर एक्स है इट इज 1 बाई एक्स, डी कंसंट्रेशन ऑफ एक्स डिवाइड बाई डी टी, यहाँ पर y आपका स्टोइचोमेट्रिक कोएफिशिएंट है इज 1 by y concentration of y divided by dt. So you have to divide the here again the stoichiometric coefficient is, you have to divide the rate of the which you take the term by any one of the reactants or products by the stoichiometric coefficient, and you have to use the instantaneous rate. In case of instantaneous rate, time limit is made small so that del a or del x becomes dx. You have to use the term dx by dt term. So in this way we determine the rate of reaction mathematically.